Today I'm going to talk about the chemical doping of organic semiconductor. So the doping in the organic semiconductor is a process between dopant and polymer. So we can consider the polymer as host and dopant as intruder. And the chemical doping can be achieved by charge transfer between the polymer and the dopant. There are two different types of the chemical doping. So the first one is the integral charge transfer. And the second one is the charge transfer complex, which is also called partial charge transfer. And both of these types has N-type doping and P-type doping. So the first one I want to talk about is the P-type integral charge transfer. Here, I draw the polymer orbitals in black and dopant orbitals in red. On the left side, the axis means the energy level and increasing from the bottom to the top. The LUMO here means the lowest unoccupied molecular orbital, and the HOMO means the highest occupied molecular orbital. And it has the electrons here. So when the HOMO of the polymer is higher than the LUMO of the dopants, we know that the electrons likes to go to the lower energy level to minimize the whole energies of the system to make it more stable. And when the HOMO of the polymer is higher than the LUMO of the dopant, the electrons on the HOMO of the polymer will like to prefer to transfer down to the LUMO of the dopant. And during this process, holes are introduced in the polymer. The holes are the positive charge, so we call the whole process the p-type integral charge transfer. P in the p-type means the positive charge. And then for the n-type integral charge transfer, here, when the LUMO of the polymer is lower than the HOMO of the dopant, then the electrons on the HOMO of the dopants likes to transfer down to the LUMO of the polymer. And during this process, electrons are introduced to the LUMO of the polymer. And electrons are the negative charge. So we call the whole process is the n-type integral charge transfer. N in n-type means negative charge. Then I'm going to talk about the second type of the chemical doping, which is the partial charge transfer. So the first I want to talk about is the p-type partial charge transfer. Here, we can see that when the HOMO of the polymer is close or sometimes is the same as the LUMO of the dopant, and the electrons on the HOMO of the polymer will have no place to go to minimize its energy, then a hybridized orbitals will be created between the polymer and the dopants. And I draw the hybridized orbital here in green color. And there is a orbital split, which will create a higher hybridized orbital and a lower hybridized orbital. And then the electrons on the HOMO of the polymer will like to transfer down to the lower hybridized orbital. And we can understand it in a way that both polymer and dopants have no space for the electrons to minimize their energy. So they create a space together that can reduce the electrons' energy and share the electrons. At the same time, we introduce the holes to the HOMO of the polymer. So we call the whole process is the p-type partial charge transfer. Then the last one is the n-type partial charge transfer. Here, when the LUMO of the polymer is close, or sometimes it's the same as the HOMO of the dopant, then the electrons on the HOMO of the dopant will like to transfer down to the lower hybridized orbital. And that's all for the explanation for the all different types of the chemical doping.